Hi, Serge.
Hi, how are you?
Hi, how are you? Hi. We are still waiting for the moderator, so please wait for a moment.
Okay.
Hi,
let's do it.
Sabrina.
Hi. Can you open your camera?
Yes, I'm
Okay.
trying actually. Just give me a second.
Yeah.
Okay, Sabrina, 很久不见。
很久不见. Can you see me? Okay. Yeah.
I'm in
Are
the
you?
right room, right?
Yes. I think.
Okay, good. Let me
I
just.
didn't see you. Please open your camera so that I can see you.
Yes, just a second.
Okay.
I have issue with my
Hello.
camera.
They already focus. Can see me. David. Hi, David.
Hello. Can you hear me okay?
Hi.
Yes.
Hi. Okay. So I think we at the time we can start. Yes. Wait for a moment. Okay. Okay, ladies and gentlemen, welcome and good morning, good afternoon, and good evening, everyone. Warmly welcome from Global Forum on Human Settlements. And it's a great honor to welcome all of you to attend PowerPoint session 3B towards smart, zero carbon, and sustainable buildings and communities. First, let's welcome the moderator of this session, David Hanks, Senior Director, Program Quality and Habits for Humanity International. David, the floor is yours.
Good morning. Good morning all, and thanks for joining. Good morning from the UK, or good afternoon, good evening, wherever you are. And welcome to this thematic session 3B towards smart, zero carbon and sustainable buildings and communities. Yes, so my name's David Hughes. I work as the Senior Director for Programme Quality at Habitat for Humanity International, and I'll be moderating this session. So thanks for joining. A bit of context. So Habitat for Humanity is a non-profit organisation that helps families build and improve places to call home. We build strength, stability and self-reliance through shelter. We work currently in more than 70 countries, and we've helped more than 39 million people improve their living conditions since 1976. So we've been working with the Global Forum on Human Settlements organising team to bring together a group of 4 speakers who are experts in their field. And in this session, they're going to share a range of insights and perspectives on the topic of smart, zero carbon and sustainable buildings and communities. Following their presentations, we'll have a dialogue session. We've got some pre-prepared questions, and we'll also be open to questions that are put into the chat. So as we're going through the presentations, if you have a question, please put it into the chat. And if it's for a particular speaker, please also note that so we can pick those up as we go along. So let me now introduce our speakers, and then we'll move on from there. So first of all, a colleague from Habitat for Humanity, Jennifer Sinelli-Uman. Welcome, Jennifer. Jennifer is the Global Director of Applied Innovation for Habitat for Humanity's Terwilliger Centre for Innovation and Shelter. She has 15 years experience applying market systems, human-centered design and systems thinking in international development. And Jennifer will give us an overall framing of the topic today and then focus particularly on the affordable housing segment. Thanks, Jennifer. So we'll talk to all the speakers initially, and then we'll go to their particular presentations. So our next speaker will be Serge Salat. Serge is the founder and president of the Urban Morphology and Complex Systems Institute, a member of the International Resource Panel of the United Nations Environment Programme, and a leading expert of International Green Model City Standards 3.0. Serge is a practicing architect, urban planner and designer, and an urban economist. He's authored more than 20 books, and he'll be focusing today on healthy green buildings and communities, linear, networked, and 3D greening. Welcome also, Serge. Thirdly, Sumaya Ben-Dao is research coordinator at the United Nations University, EGOV. She's also an assistant professor in management of information systems discipline lead at South Mediterranean University, and she additionally coordinates the program in big data and business analytics at the Mediterranean School of Business. Sumaya is going to be focusing today on exploring blockchain for healthy, smarter, and zero carbon cities and communities. Welcome also, Sumaya. And lastly, Mr. Chang Hao will be our fourth speaker. Mr. Chang Hao is the Vice General Manager and Professor Level Senior Engineer at the Hawaiian Electric Power Research Institute. He's also a member of the Standardization Technical Committee of Electrical Equipment Quality Management of the China Electricity Council, a member of the Central Enterprise Energy Conservation and Emission Reduction Experts, and a member of the Clean and Low Carbon Power Generation Committee of the Chinese Society for Electrical Engineering. And he'll be sharing today on new type distributed energy development in the context of carbon peak and carbon neutrality goals. Welcome also, Mr. Chang Hao. So now I will ask Jennifer to start our presentations, and a reminder, please to put any questions in the chat as we go along. Jennifer, the floor is yours.
Okay, apologies. Hi, my name is Jennifer Oman, and again, thank you, David, for the introduction of this hopefully very interesting session. I'm going to start off by just reiterating what David mentioned about Habitat for Humanity International. We're an organization operating in 70 countries around the world, and we realize a vision of a world where everyone has a decent place to live. Focusing on affordable housing and allied services as really the foundation for families' health, well-being, and economic empowerment. And we do that by working at the community, the sector, and the societal levels, and increasingly focusing on climate change. The housing deficit globally is massive, and it is growing every day. It's both qualitative and quantitative in nature, meaning that a group of low-income people may have a home, but it may require, for instance, an upgrade, improvement to ensure it's resilient against disasters and that it's habitable. 70% of the population globally is urban. 70% of the structures of a city are housing, and 70% of that housing is built actually incrementally by people like this couple here, Ed and Gina. They live on peri-urban part of the city of Metro Cebu in the Philippines, which is on the Pacific Ring of Fire. And they built their home incrementally over many years on family land when money and materials are saved up. They have no foundation and a very tenuous roof situation and experience typhoons every year. At the same time, with that reality of affordable housing, 25% of carbon emissions are coming from the residential building sector, which includes both the embodied energy in the materials and the operational energy. It's a huge footprint, and I don't think it's often spoken about nearly as much as it should be, although I do think that's changed at recent COPs. We are seeing lots of efforts now by NGOs, the private sector, the public sector, coming together to think about how to reduce carbon emissions, particularly via housing. And one area is certainly in looking at how to reduce the intensity of the building materials, looking at smart, low, and clean energy sources, designing more recyclable materials and alternative materials that could be used. But at the same time, looking at how do we build that resilience against the consequences of climate change that are very much felt right now. Doing that through preparatory measures against disasters, looking at heating and cooling and really overhauling that concept. This picture's taken in India where temperatures are reaching, 45, 50 degrees in the summer months. So really thinking about that resilience aspect today. And what we know as Habitat and what we've seen in working with these communities is that the most impacted by climate change are also the most affected by the global housing shortage. And any measure that's going to support climate change, both from a mitigation or adaptation perspective, must incorporate housing needs. So I'm going to share a couple examples of our work globally. And the first example we're going to look at is about energy savings and efficient use of energy in house construction in a way that engages communities in that solution. So this is a picture of a home in Sri Lanka. It's made of compressed earth block. Now, compressed earth block is not necessarily a new technology. It's actually available in many geographies. But it offers a lot of environmental benefits. I think one is that it reduces the need for sand that is often mined from riverbeds. It has a lower carbon footprint because it's not burnt the way many bricks are produced. In terms of resilience against warming temperatures, it often regulates, it regulates quite well, meaning that it's cool during hot days and warm during cold nights. So it sounds like a win-win type of product, but it's actually not that widespread in its adoption. And Habitat was curious to explore why and look at this from a new lens or a new angle that really engages communities in that question. And that's what we did in Sri Lanka in the Homes Not Houses, Building a Sustainable Futures Together project. The goal of that project was really around raising access and awareness to environmentally friendly materials, but we did have a focus on CSEB. Now, this didn't look at just building homes. It looked at training community members and small business owners. It looked at training people in appropriate technologies and techniques. And yes, finally, it did also build houses. And of the more than 1,000 built in that area, 700 were using the CSEB technology. The second example I want to draw from is focused on innovation in construction systems and materials, looking really at recycled content and circular building materials. You know, a couple of years ago, Habitat was running our startup accelerator, supporting young entrepreneurs. And we actually were finding that about 25% of all applications all over the world were actually coming from recycled or circular materials, with a strong focus on actually recycled plastic and the role that recycled plastic might play in the built environment. The idea is to take plastic waste that wouldn't otherwise be recycled or has like essentially no value, and encapsulate it somehow in building materials. In Costa Rica, we partnered with CRDC Global. They have a Resinate product, which is a concrete additive, and it can be incorporated in all kinds of building materials. And partnered with them to think about building homes actually in Costa Rica. And in the Philippines, on the other side of the world, working with green ants, which is pictured here. This doesn't look like a plastic brick, the way you might think of it if I say plastic brick, but this has incorporated plastic waste into the brick through a proprietary mixture, displacing some of the cement and sand additives. So in this case, Habitat's support to green ants was more on the business model and saying, how do you move from the middle income segment to the low income segment? Is this an appropriate product for the incremental builder? And how do you add value there? And so we looked at bundling the product with design services, like architectural services, developing career pathways for different artisans, and also offering financing through hardware stores where people go to actually access their materials. These are all services that add value for that incremental builder. And at the same time, we couldn't just look at the material, we needed to look at the regulation. Regulations support innovation. And even in the US, there are regulatory barriers to certain kinds of different innovative materials like recycled plastic, and saying, how can we unlock innovation barriers broadly for new innovations to come into the market? Not just plastics, I mean more broadly than that. The final example I want to provide is from the residential energy efficiency project that we've hosted in Central and Eastern Europe. Energy efficiency is a major issue there. after the privatization of buildings, ownership of multi-apartment buildings was left to residents. And oftentimes there wasn't agreements in place. So common space might, like even the roof might fall to disrepair. So the project looked at the effect that transition had on energy poverty, specifically, this idea that low income people with have unaffordable heating bills. I think many people are feeling that this year particularly, and the low income more acutely. And so one of the most effective and sort of sustainable ways that we were able to address this was to look at changing consumer behavior around heating, and also retrofitting buildings so that they were more insulated with quality material. And so working with homeowners associations, financial institutions, local government units, everybody needed to be engaged on this issue. Just finally, the key learnings from, I think, these 3 projects and many other that Habitat is involved in, solutions are widely available. Entrepreneurs are rising to the challenge, but we have to unlock innovation barriers and enable them to find the way and the solution in their local communities. The enabling environment, working with governments and regulations, is very important in order to support the adoption of such innovations. And partnering together, you can never say, I think you can never say it enough, but partnering together with communities is important. So we've put out a recent report. We'll link it in the chat for those who might be interested in reading more broadly about some of our experiences here. And I just want to pass it back to David. Thank you very much.
Thanks, Jennifer, for a rich presentation and for bringing an overall perspective and also getting into some specific examples to help to think through more factually on those. And I'd encourage everyone, be thinking through these themes as we're going through each of the presentations. If you've got any questions, put them in the chat, and then we're going to look at the end how to bring together the themes and what the key next steps are. So now I'll thank Jennifer again and pass this over to Serge. Please go ahead, Serge. The floor is yours.
Thank you. So just a few words of introduction. I'm very proud to have been working with the Global Forum of Human Settlements for so many years, probably something like 13 years now, and I've been the lead expert of the Standard 3.0. And I'm going to focus on, and I'm also working a lot with the United Nations at the moment, and I produce the UN Environment Integrated Sustainable Neighborhoods Design Guidelines, and we are developing a MOOC also at the moment, which will be translated in 6 languages, including Chinese, and accessible for free on an online platform of the World Resource Institute. So I'm going to focus on a specific topic, and let me share my screen, which is nature-based solutions. And why is it blocked? Okay, let me try to open this. Yes, but well, sorry, I'm just trying to figure out why. Okay, but why I cannot open it and move it? Sorry, it just like it looks like it is on the right-hand side.
Do you need me to show it for you?
Yeah, maybe that could help, because I don't understand why it's...
Okay, I can try. Okay.
Yeah, I think there's always going to be some technical issues come up, so I'm sure we'll find a solution.
Oh, okay. Now it has moved. So, okay. Now with sharing, Sabina, you're sharing. Okay, fine.
Okay.
Let's do it like it. So I'm going to focus on nature-based solutions integrated into the urban fabric at many scales. So healthy green buildings and communities, linear networked 3D greening. Next, please. Okay, life outside buildings, first thing, is as important as what happens inside them. Green, water, light, and health combine to create a public realm that is rich in natural green life. The well-being of those who live and work can only be enhanced by such a close relationship with nature. So the relationship with nature brings, first, it reduces the heat island effect. So it has a super positive effect on carbon emissions because we need much less heating energy. It regulates the water flow, and it brings amenities to people. But this is absolutely not something new. Next, please. Sabrina.
Yeah.
Next.
Okay. Sorry.
Okay. Nature should be integrated, and how can we make it efficiently? Nature should be integrated at all scales in the urban fabric of healthy and zero carbon communities. This is a project I designed in China, in Hangzhou, actually, where we use the water and we recreate the mountain like the feng shui Chinese landscaping, and we weave green at each level into this village, which actually is a smart city for deep tech and innovation and industry 4.0 development. So it doesn't look at all like a deep tech environment because of this smooth integration of nature. Next, please. There will be 4 parts. I will try to go in 10 minutes through this. Lessons from historic cities, green cities and blocks emerging from the green landscape, linear green connectors for urban regeneration, networked green for urban regeneration, and 3-dimensional green, that is regreening more than 100% of the original plot. Next, please. So first key message, cities of the historical cities were totally embedded into natural landscape. They were not like now, totally sprawling everywhere and totally segregated. From everywhere in the city, this is Firenze, you could see the nature, you could see the fields. And next, please. And the fields were actually, and urban agriculture was totally integrated, and the water was totally, I am in Bruges at the moment, which is a water city like Venice. The green, as you see here, you just have the center of the city. You have houses. I'm speaking from one of these house types at the moment. It's absolutely wonderful. The houses were along the blocks, along the streets, and the inside of the block was entirely green and cultivated or with beautiful gardens. And this is the right way to build cities, actually, to have streets, houses, or along the perimeter of the block, and to have a super green block inside. Next, please. This is Paris. Next, please. We won't have time to elaborate on this. This is Amsterdam. Amsterdam in the 17th century was planned along the canals, which were going into the fields for the irrigation. Next, please. And this is an illustration. When you move in Amsterdam, you may feel that you have the canals, you have the facade, but this is the inside of the Amsterdam blocks. And as you see, it's entirely green. Next, please. But at the same time, well-defined. It's very urban environment. Some benchmarks here. This is in London. You have these row houses again, where you see the layers of green, like we have done in the smart city in Hangzhou. You have layers of green behind the houses, and you have a common park in front of the houses, which is a small pocket park. It's 190 meters by 26 meters, but with a strong variety of different ecosystems and of different ambience and environments. Next, please. Okay, here you see the houses facing the park. Here you see the different areas within the park, and you see how you can create a super great micro landscaping, having very diverse landscapes, even within a small pocket park. Next, please. And here you see turning around the block, where you see on the right-hand side, the green getting behind the houses. And here you see the movement from at the bottom, from facing the park, entering the house, being into a room where you see the green, and then you can go behind the house where you have again a more informal green for the use of the individual owner. So you have these different levels of public, semi-private, private, entirely privatized, and very small green. Next, please. Okay, and this can be perfectly recreated in, this example was mid 19th century, but this can be perfectly recreated in contemporary green blocks like in Hammarby Sjöstad. Next, please. Okay, where you see this is a quality program, and you see the same absolutely principle with a contemporary design, which is applied in an eco neighborhood in Sweden, with a common garden, with the inside of the green blocks, and with everything I've been showing you in London. Next, please. Urban linear green for urban regeneration. One key message I want to share with you is that green should be connected. And to connect green, you can make it with linearly. This is High Line in New York. We're going to go fast on it. Next, please. Okay, the first one key message is also green is not just an informal piece of nature everything I've been showing you at the moment is very well designed, and the High Line is very well designed with different and it's imbrication, it's interweaving of architecture and green. It's not just next, please. And with also different ambiances, where different atmosphere, where you can sit, you can relax, you can walk. You have different patches of a more wild environment and more natural environment. But then you have social activities. The third picture on starting from the left, and then a more dense New York environment. And this is what creates it's not like putting a piece of a forest inside of the city. It's really about designing the nature. Next, please. And here you see the different ecosystems: the pit, the plains, the bridge, the mound, the ramp, the flyover, and this ensures the high quality of this linear park. What I want to really stress the difference between the green space, which is something which is absolutely meaningless, and the park or garden. A park or garden is green space plus design. Next, please. Okay, and here you see the work of the architects and landscape designers. Next, please. Okay, now networked green. The example here won't be the High Line in New York, but will be King's Cross in London. Next, please. First, but I have no time in 10 minutes to develop. The key message here, and you can read this slide take more time, is the granularity of the green. In an area of 12 square kilometers in Kensington and Chelsea, you have 13,000 people per square kilometer, so it's a rather dense area. But you have 78 hectares of public green space, 28 parks, 2 cemeteries, 60 green spaces, plus 235 private open space, comprising 88 private squares, like the one I've been showing you in Pembridge Square, the one before. Gardens accessible to surrounding residents. And then you have each park as its individual history, landscape feathers, user group profile, and local community. And each park is different. It's a different feel and essence. It's not just greening the side of a highway like in many Chinese cities. The borough totals 166 hectares of green space, 14% of the land area. But when you had the big parks like Kensington Park or Holland Park, which are really accessible on foot, I have been living in this area, so I know very well. You have a total 36 square meters of space, of green space per resident. Next, please. And this is a legacy of history. But in new project like King's Cross in London, the choice was done by the developers to devote 40% to green space, but not like a big park in the middle of the development, but really to weave and to create 10 new pocket parks inside the development. Here you see the master plan. And here you see that, oh, it wasn't, all this is an entirely new creation. Next, please. Yeah, and here you see the different ambience. Pancras Square, which is triangular and which has water getting down, sloping down towards the tower of the and the clock tower of the station. Next, please. Okay, here you see the 1,000 fountains, which is also a garden of water in front of Granary Square. And they have kept 20 heritage buildings. It's a small area, it's 27 hectares, but you have 10 heritage buildings. Here on the back, you have the gas holders, and it's super people-centric. Next, please. Okay, and you have some more formal, some more, and you have the very rich ecology, and you have the Camley Street Natural Park, it's like a small stretch of nature right in the middle of London. Next, please. Along the canal, which has been created at the time of the railways, and then you have Lewis Cabot Park, and then next, please. Next, please. So many material, and then you have this garden, which is like a work of art just before, but we have seen it. And then you have the new addition, which is the Google headquarters, which is a 300 meters long garden on top of the building. Next, please. And this will be the end. The three-dimensional green. So what is the next step? Is and actually, when you see that, all the green is not on the ground. The green is on the 4th floor and the 7th floor. This is Kampung Admiralty in Singapore, which I like very much. Next, please. Okay, so green intensification is a process tailored to different climates. In hot and humid climates like Singapore, the outdoor green can expand in 3 dimensions with sky gardens and lush green roof and into a porous urban fabric. Next, please. This is a project I have done with my students in Singapore. So this is a section of Kampung Admiralty, and now you see, compared to the view from the sky, that you have the green and the amenities for the children are at the 4th level. You really look like a recreation of nature, and then you have stacked. It's a super mixed use area with a food court. You have a healthcare center, the blue one on 2 levels, and then you have elderly and children amenities, and then you have the housing, and you have a communal farm, which is extending vertically from the 4th floor to the 7th floor. Next, please. And here you see some pictures, and here the picture on the right, on the top right, it's really the communal farm. So you just look, and you are right in the middle of Singapore. You just are really surrounded by green, and the pictures on at the bottom are the health center and the children's playground, which are at the 4th floor. Next, please. And this is a project I have been advising in Guangzhou, which is the Sino-Singapore city. And we have made with the World Bank and with the Guangzhou planners the Knowledge Valley, in which we increase at a bigger scale the principles of Kampung and Admiralty in Singapore. Of the 3D green, the 3D green regreens more than 100% of the original plot. So, and here you have the exactly that. Buildings are crafted with a diversity of 3D greenery, sky gardens, vertical greening, and green roofs, creating a 3-dimensional urban forest. Hollow buildings, like to increase the flow of air, allow breezes to infiltrate. Next, please. Yes, and it's a hilly micro topography. We have recreated the 3D landscape in this Knowledge Valley, low-lying areas rain gardens, wetland parks, a tidal landscape of green areas is water, and water is fostered. So it's a combination of urban space and the recreation of a urban landscape and a topographical landscape. And the architectural design takes the connection with fields into full account. The use of steel, three-dimensional setbacks, other techniques are integrated with nature, elevated floor, staggered floor. So once again, design, 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 design. I've been showing you design from the past to the most contemporary, and you see that it's not just nature-based solution, it's designing with nature. Next, please. And this is the final one. So for achieving this, you need to create a long-term vision of a green city with the local authority. That's what's happening in Hangzhou and in Guangzhou, and Chinese cities are really forward-looking and very impressive on this. Develop master plans around the green landscaping vision. So not just a classical, absolutely not the classical way of developing a master plan around roads, but developing a master plan from a landscape project. Integrate green spaces with all infrastructural projects, housing, transport, business parks, community and health facilities, and urban rehabilitation approach. So not just creating a master plan and greening it, but creating the master plan around the green landscape, and engage, of course, the local community. Have a long-term perspective while remaining flexible. Green spaces are long-term investment. They may need some time to establish before they are fully usable, and they require long-term maintenance. The benefits may only become apparent over time. That's why with the World Bank, we make a lot of green spaces, ecosystemic accounting of the benefits for making the case for the green spaces, because they cost money, actually. You must not think that it comes like just for free. But they bring much more benefits than they cost. Urban green space should be planned and designed in a flexible way, also making functional adjustments possible to adapt to changing future demands, which increases their resilience. So, but the very positive message I want to convey is that this legacy of the past, that you see in green cities like London or parts of London like Kensington and Chelsea, you can really recreate pieces of it by design and planning, and you can even create much more ambitious green projects like the Singapore or the Guangzhou Sino-Singapore city that I've been showing you. And on this, I conclude my speech.
Great, thank you, Serge. Thank you for your long-term commitment to the GFHS process you've been talking about there, and yeah, a really rich, again, combination of historical examples of how cities can be built with nature and greening in mind, and around those frameworks, but also modern examples which hopefully people can relate to and think through, possible uses of this type of approach in their context. So I think again, really great content there, and looking forward to picking up more in the dialogue at the end. And again, please be putting in any questions that come to mind into the chat box. So now we're going to ask Sumaya to come forward, and please share with us. The floor is yours.
Thank you very much for the invitation. Thank you for Global Forum and Human Settlements. It's the second time that I'm participating to this very interesting conference. So since a couple of years, we are working on trying to explore the use of technologies in general, emerging technologies, frontier technology, in how it can help cities and sustainable development, and trying to see how we can help and observing basically blockchain, AI, IoTs, and all this frontier and emerging technology to contribute to more healthy, smart, and zero carbon cities and communities. So I'm a research coordinator of a research line which is on innovation and emerging technologies, and we are looking into in general how we can support global challenges and support governments, cities, municipalities on facing these global challenges through digital transformation, through the use of technology, through the adoption of technology. And we are trying to promote a more responsible use of technologies, and basically how these technologies can contribute to sustainable development goals. And particularly, it's very recent that we are looking into the environment technologies and how it can support the SDG 7, for example, affordable and clean energy, among others. So basically, under this, sorry, I cannot. Yes, under this research line and the different research that we are conducting, it's very clear, and there is no doubt about that there is a potential on emerging technology and how it can help on looking into innovative solutions and how it can play an important role in ensuring that cities are more people-centered, inclusive, safe, and recently more resilient to crisis and environmentally friendly. So there is more and more investment on digital transformation from government, from cities, from companies, and it's going increasingly. So it's exponentially increasing. But it's important to look into how this technologies and the investment on technologies are going in the right direction and not creating more harm environmentally and socially and economically as well. So from our side, we are looking into the implication and how we can use blockchain in the right direction. So we have explored blockchain technology, and we have prepared a report in collaboration with UN Habitat and UNEC under the umbrella of United for Smart Sustainable Cities on blockchain for smart cities. And it happened that we looked into many cases, and we've seen that there is an interest, an increasing interest from municipalities and cities on the use of blockchain technology. And it appears through the case study that it's particularly recreating the trust that is a problem between the government, the cities, the municipalities, and the citizens for boosting more through the boosting of more transparency and traceability as well in smart cities, creating this IT decentralized IT infrastructure to be able to manage this growing networks of stakeholders, of partners, of participants, citizens and residents in the cities. So we have observed many use cases in healthcare, in education, in finance, in many areas. And it's very recent that we are seeing initiatives in more a green area in environment. And it's extremely new, I will say, but there is some effort. As earlier Jennifer was saying, there is many challenges in management of energy, in management of carbon-related issues, in carbon emission, in housing, in many areas, in energy saving as well. And it's very recent problem that we are facing, and it's a huge issue nowadays that we are facing, and we are looking into how this technology is working to support this effort on energy saving, on better monitoring of carbon emission, and all the energy related and environment related issues. So some blockchain application have, we know that from the blockchain use history, that there is a lot of issue related to the use of blockchain by itself. And we have seen that there is some applications such as blockchain, such as Bitcoin, for instance, that are environmental polluters with their massive energy consumption and green gas emissions. So Recently, there was lots of effort that have been conducted, lots of research and development to make this technology more energy efficient, and depending, of course, on the choice of network architecture, on protocols, and all the effort on research and development. So there is a research and development as well on looking into how blockchain can support distributed energy networks. And there is many examples that we have seen in the South Italy, in Netherlands, in Amsterdam, looking into how blockchain can help in facilitating the reduction of transaction cost, for example, involving the citizens in any energy through incentives, simplifying transactional processes, and providing social values through the traceability, through more transparency, through improvement of participation, and also in the use of data. So blockchain is a really relevant, have many potential to manage the data underpinning the distribution of clean energy infrastructure, for example. And in combination with the right technologies such as IoT, for example, or AI, blockchain could be applied to address challenges related to growing diversity in climate markets, and at the transnational level, environment, on the regional level, but also at the city level. So we have observed many examples, mostly energy related or carbon offset related. So there is example of blockchain supporting peer-to-peer energy trading, for example, with decentralized system that where we can use the renewable energy in an optimized way, enabling a smart contract application. For example, we've seen that in the cases of the power ledger in Thailand, in India, or in Malaysia. We have also, in addition of that, and the example, the use case of EW origin in Turkey, in Salvador as well, highlighting how blockchain technology have the ability to support a centralized marketplace for renewable energy and sharing renewable energy certificates as well. So because we all know that in developing countries in general, this type of market suffer from high administrative costs and dependency on intermediaries, lack of transparency as well, and the risk of corruption that we are facing as well. So among other challenges we have that we have observed. And this is very essential to develop more transparent and accessible market that is affordable for energy. There is also examples related in Sun Exchange in South Africa that is related to financing option. For example, there is also the case in the area of carbon offsets, trading and digital measurements, reporting and verification of greenhouses and gas emission. Ledger here and the blockchain are used for more trustworthy and transparent carbon credit data and carbon credit exchange between companies, or and through the management of the city and the municipality, or by companies themselves exchanging. So we have the market in China, in Chile, and in many other examples that are under the exploring this type of technology. There is the example as well of digital MRV, where there is automation. Actually, it's an accounting system that is put in place in order to automate the measurements and the reporting and the verification of processes related to the carbon emission. And this is very interesting because we've seen it's contributing, and there is an increasing interest on how this type of big issue concerns ongoing about with global warming and in many cities, and particularly in a very industrialized city, what they can do to reduce their carbon footprints. So we are observing that there is initiatives, increasing initiatives related to the carbon offsets and many other efforts related to the global warming, but it's still under research. As you may know, blockchain equipment such as cryptocurrency are using this type of technology. So this technology is trying now to be used in a more a useful way and contributing to the energy and to the climate change and global warming issues. So in this sense, we've seen more than 65 initiatives addressing in general, not only carbon or climate related issues, but environmental issue in general. Some of them are at the very early stage, some of them are ongoing, some of them are at the pilot stage. There is no a single initiative that is out there operational so far. So it's still under development. But there is a clear potential that have been observed in resource rights, in product origin, in incentive system earlier. Jennifer was talking about changing consumer behavior related to energy consumption. So this incentivized system are trying to motivate citizens and residents in using, in saving in their use of energy through the use of blockchain technology, for example. And there is also many efforts in the development of alternative protocol to create systems that are reducing the energy intensity. So to conclude my key messages, it's important to support and promote a responsible and cautious use of blockchain technology. As I said, is in one side there is negative aspect in the massive consumption of energy, but at the same time it can there is potential and opportunities in using blockchain technology and in the exploitation of data to address environmental, social, and economic challenges. So blockchain technology can play a part by making possible more accurate and reliable monitoring, generation, and distribution of renewable energy through the efficient use of data. But it's important as well to address the negative and challenges related to blockchain technology and related digital technology. So blockchain it's developing rapidly, and policymaker also needs to contribute to future energy system while mitigating the risks related to the use of this technology, I mean the environmental risk. So to finish this presentation, with the right policy, digital technology can give an unprecedented boost to sustainable development, particularly for the poorest countries. And this was one of the quote from the UN Secretary General Antonio Guterres this year during the G20 summit. Thank you very much. And I will be happy to share more information about our research on blockchain and AI for a smarter, greener cities later during the discussion. Thank you very much.
Great, thank you, Samaya. Thank you for your research and engagement in this area, and for bringing out those examples. And I particularly like the way you've picked up both on the issue of addressing energy efficiency of blockchain and related methods, but also how can we use those in a smart and responsible way to contribute to overall energy efficiency. So some really great food for thought there. And we'll definitely come back for more on the questions. So now I'm going to pass over to Dr. Chang, so Mr. Chang, for the final presentation. Please, the floor is yours. Thank you.
Wait a second. Mr. Chang is muted. Can you hear me? Okay, we can hear you. Keep going. Okay. Dear experts, dear colleagues, good afternoon. I'm really happy to be here with all of you. My name is Chang Hao. I'm from Huadian Electric Power Research Institute. And our company has a large scale, and we have done a lot of research about distributed energy. And this is my third time at the forum, and this is my second speech at the forum. So today I'll talk about how we can develop new type distributed energy under the dual carbon goals. The dual carbon goals refer to our goals of reaching carbon peaking by 2030 and carbon neutrality by 2060. Just now, a lot of experts talk about energy efficiency and distributed energy. Actually, distributed energy is quite important. Distributed energy is kind of independent. At very large airports, very large exhibition centers, industrial parks, amusement parks, large communities, and large school campuses, distributed energy has been used a lot. In our practice, we have done really a lot of research in this aspect. We are kind of the leader in this aspect. So my speech has 4 parts. In the first part, I'll talk about the role and the position of distributed energy in our energy transition. In the second part, I'll talk about the trends in distributed energy. And in the third part, I'll talk about our practice. And the final part is a short summary. So let me get started with the first part. In China, we are working hard to achieve our dual carbon goals. So the time nodes for achieving carbon peaking and carbon neutrality are 2030 and 2060 respectively. Solar PV and wind, those are very important renewable energy. And PV and wind should account for about 50% of our total energy. That's our target, and we're working towards that. So we want to ensure all the electricity here in China is clean. On the production side, we want to replace fossil energy with clean energy. And on the consumption side, we want to lower the total carbon emissions from the whole society. Building a new type electricity system or power system is a cornerstone for achieving our dual carbon goals. So currently, our existing power system is not adequate. There are many challenges. For one thing, the energy or electricity from new energy cannot be really stored effectively. So wind and solar are intermittent. How can we really handle that kind of intermittency and fluctuations? Also, we got to ensure we have better peak shifting to ensure a better load balance on the whole system.
Okay, second part, I want to talk about, I want to introduce to you our distributed energy system. In order to meet the development needs of the new power system, the traditional distributed energy should develop in the direction of clean, low carbon, and intelligent, and some other aspects. So we propose the construction of a new distributed energy system model to help achieve the 2 carbon goals. Our new distributed energy system, the new distributed energy system, or NDES, is a new comprehensive energy service model based on the renewable energy input and multiple energy complementary and some nearby supply to meet the low carbon demand of the customers. And the figure below is our vision of a new distributed energy system. The energy production side includes a high proportion of solar energy, wind energy, and biomass energy. So using hydrogen energy as the carrier to realize the transfer and transformation of energy in time, space, and grade. The energy consumption side takes the nearby supply as the main principle, and we meet the energy conversion equipment of fuel cell, gas turbine, internal combustion engine, refrigerator, and electricity storage and cold storage. And I want to introduce to you several key technologies of NDES. And first, the multi-energy complementary system integration technology. The new distributed energy system includes the energy production and the energy conversion process. Energy production includes a high proportion of new renewable energy sources such as solar energy, wind energy, biomass, and geothermal energy, as well as traditional fossil energy sources such as natural gas and coal. The energy conversion process includes fuel cell, gas turbine, internal combustion engine, refrigerator, electricity storage, and cooling equipment, etc. In order not only to realize the coordination of renewable energy and fossil energy, but also to meet the efficient conversion of energy, it needs to conduct in-depth research on the multi-layer systems such as basic theories and technical methods. Well, secondly, a low carbon, zero carbon power equipment. The low carbon or zero carbon power equipment is an important factor that directly restricts the development of distributed low carbon and the development of hydrogen dope and hydrogen-rich pure hydrogen internal combustion engine, gas turbine, and fuel cells are critical. So it is necessary to accelerate the development of major equipment by relying on major projects. And thirdly, the distributed energy storage technology. This technology is a form of energy storage configuration with small capacity and power, which can be stored through electricity, heat, cold, and other forms. The application of the scenarios of distributed energy storage can be divided into power generation side, distribution network side, and user side, and the microgrid, etc. And fourthly, the electric thermal composite energy storage technology. This is it is urgent to develop a system-friendly, multi-scene electric thermal composite energy storage technology with high security, low cost, long lifespan, and intelligent operation and maintenance. And fifthly, the flexible gas electric conversion technology. The gas electric flexible conversion technology is through renewable energy. And sixthly, the intelligent control and optimization technology. Oh. Okay, yeah, I'm sorry. And the third part is that we are currently carrying out the research and practice work related to the new distributed energy sources. Due to the limited time, we will choose there are three directions to share with you, all experts. The first is in the integration direction of the multi-energy complementary system. And based on the National Energy Distributed Energy Technology Research and Development Center, Equipment Platform, and the National Key Research and Development Project, at the same time, we combine the Engineering Institute of Thermal Physics of Chinese Academy of Sciences in view of a variety of energy grade characteristics and complementary mechanism has carried out the research, put forward the complementary and the collaborative mechanism of cascade utilization. And secondly, a second is the direction of low carbon or zero carbon power plant. the hydrogen energy will be an important starting point for the green and low carbon transformation of traditional energy. And the third is the distributed energy storage direction. Relying on the National Energy Distributed Energy Technology Research and Development